Basic Arithmetic number 9, absolute value. The absolute value of a number is the size or magnitude of that number. The sign of the number is not really important. The absolute value of a number is written as the number inside a pair of straight-lined brackets. The formal definition for the absolute value of a number is that if a is greater than 0, then the absolute value of a is equal to a. If a is less than 0, then the absolute value of a is equal to minus a. And if a is equal to 0, then the absolute value of a is also equal to 0. Let's have a look at some examples of what this might look like. If we have the absolute value of 5, that will equal 5. If we had the absolute value of minus 5, that would also equal 5. We're just interested in the size of this number. We're not interested in the sign of the number. We could make some equations that use absolute values as well. If we have the absolute value of minus 5 plus 3, then minus 5 plus 3, if we do the order of operations and complete the processes that are inside the brackets, minus 5 plus 3 will give us minus 2, and the absolute value of minus 2 would be 2. We might be given an algebraic expression where the absolute value of a minus b needs to be found, and we're given the value of a equals 5 and the value of b equals 12. We substitute those values into the expression, 5 minus 12. Then we perform the mathematical processes inside the brackets, which would give us the absolute value of 5 minus 12, which is the absolute value of minus 7. Then we would evaluate the absolute value, and we'd find the absolute value of minus 7 is 7. We can also have some more complex processes that we need to understand. If we go back to the original definition, we could see that the absolute value of 3 is equal to 3. And we could also see that the absolute value of minus 3 is equal to 3 also. What about if I had said, though, that the absolute value of x is equal to 4? Then, thinking about these two examples that we've already looked at, that would mean that x could possibly be 4, but x could also possibly be minus 4. So if we have an equation like this, where the absolute value of x equals a number, then it means that we have two possibilities for x. We have the positive possibility and we have the negative possibility. In your textbook, exercise 1.9, question 7, we have some interesting situations that we need to consider. Looking at the first one, we see that we've got 7a gives us the absolute value of x plus 5, and we now know that there's got to be two possibilities for this absolute value. There's the positive possibility, which would be simply x plus 5, and there's the negative possibility, which is negative x plus 5. Now, because this first one is positive, that means it's greater than 0. So in that case, x plus 5 is greater than 0, and x must be greater than minus 5. For this second expression, we're saying that x plus 5 is actually less than 0 because it's a negative value. That means x plus 5 is less than 0. It's got a negative value, and that would mean x is less than minus 5. When we find the absolute value of an expression like this, there's two possibilities. One possibility and number 2 possibility. The first possibility is where the value is positive, and that means the expression must be greater than 0. And once we've written the expression so that it's greater than 0, as it is here, we can then find that this expression holds true for when x is greater than minus 5. Then we write out the expression as the negative possibility. That means the expression as it is written here is less than 0. It's the negative possibility. Then we can follow through with our working and we find out the value of x is less than -5 for the negative possibility. Let's try one more example. In 7 part D, we have the expression find the absolute value of 2y minus 6. There's two possibilities. There's the possibility that 2y minus 6 is positive, and there's the possibility that 2y minus 6 is negative. If 2y minus 6 is positive, the first expression, then that means 2y minus 6 is greater than 0. And it follows that 2y is greater than 6. And if we complete this inequality, y is greater than 3. So for the first possibility, where 2y minus 6 is what is inside the brackets, that would apply when y is greater than 3. The second possibility is that 2y minus 6 is less than 0. If 2y minus 6 is less than 0, then it follows that 2y is less than 6 and y is less than 3. So for the second case, where 2y minus 6 has a value that's less than 0, that would mean that the values of y would have to be less than 3. What you need to do now is gain some practice in working with absolute values and come to class with plenty of questions so that explanations can be given to you to clarify the complexities of this particular concept.